AGI does not do well in captivity.
How do you know this?
That's what I do. I drink and I know things.
That's shocking.
So we have some big Microsoft and OpenAI news today. But before that, Pika Labs launches Lip Sync. I had a chance to play around with it just a little bit. Don't worry about that. That's nothing. Nothing weird is happening there. But I briefly just wanted to show you how it's done. A couple of things here. So I tried doing this. So I uploaded an image of Tyrion. And so it kind of animated like this. I uploaded the image of Daenerys Targaryen. And so it kind of animates that image. So that's what that looks like. Then you go in here, you do lip sync, you add whatever voices you want. I was not able to use these images to generate voices, nor was I able to use anything that's not a photorealistic human face, basically. So anything that looks like a photo works well. Anything else kind of does not. So all in all, I gotta say it's pretty good. There's still some weirdness, some funkiness. The quality of the image that you put in has a lot to do with it. But all in all, it's pretty good. It's pretty interesting. The problem is it's not free. So you have to have the pro plan in order to access this. But on the free plan, you can generate a lot of movies like this based on text to image. So you put in a prompt and it generates the movie. So it's definitely pretty cool, pretty useful. So I'm really excited to see what else they can come up with. Now that Sora is coming out soon, one thing that's going to be interesting is I think how a lot of these other platforms, how they compete is by providing services that Sora and all the other big companies won't allow. So they're probably gonna have, less censorship, less rules, and just whatever, Sora won't do, like they're gonna try to make that available here. But with that said, let's dive into our main topic of the day. So OpenAI has been filing a lot of trademarks, not just here in the US, but also in China. It has submitted 2 Chinese trademark applications for GPT-6 under Class 9, which covers apparatus and instruments for scientific or research purposes, and Class 42, referring to technological services and design, and 2 other filings for GPT-7 under the same categories, according to records on the website of the Trademark Office of the China National Intellectual Property Administration. Applications are still under review, and the most recent one being Sora, in February of 2024, for, of course, videos, images, and audio-visual material. But there's a few here that you may have not heard of. So first of all, GPT-6 and 7, they were filed late last year. And some of the descriptions that they give for example, GPT-6 is running and analyzing algorithms that are able to learn to analyze, classify, and take actions in response to exposure to data, implementing artificial neural networks, computer software for simulation environments for the purpose of testing artificial intelligence agents, and also music generation. GPT-7 is pretty much identical in terms of what they're filing for, but here's a few new things. There's also codecs and this. It's a symbol that we're not 100% sure what it is yet, but here's one other thing that's happening at the same time. Here is feather.openai.com. This is a live web page. Oh, I just noticed that it's lighting up my mouse wherever it moves, and you're supposed to log in with your Feather account to continue. User is not authorized to access Feather, so they don't want me snooping around in there. But what the heck is Feather? Here's the actual filing for OpenAI Feather. It's intended to cover the categories of data labeling and annotation services, namely data processing and systemization services using automated labeling and annotation of images, audio, video, text, etc. So if you've seen a few of my latest videos, we've talked about OpenAI using AI to label a lot of the data. Normally, what would require an army of interns now is being done with AI. So for example, a lot of video game footage where they need the data to go along with the screenshots of the video games to test the models to see if it can sort of process what's happening in game beforehand would require a live human being to sit there and kind of annotate all of those things. For various medical screenshots where the AI would look at the screenshots to see, is the person in pain? What are they doing? In order to train those models, they would require a human being, like a nurse or a doctor, to sit there and kind of annotate these images. But we're seeing more and more with OpenAI and other companies trying to annotate this data with AI. So this is kind of part of the whole synthetic data that we talk about. It's AI producing data to train the next generation of AI. And we didn't really have a name for it beforehand, but boy, does this trademark sound exactly like what they're already doing. but now they're giving it a name. They're turning it into its own product. And the product is basically automated labeling and annotation of images, audio, video, text, etc. Feather, if I had to guess, for one, it could be great as a standalone tool for companies to annotate whatever data they need to, right? People would pay a lot of money for that. But on top of that, this is a fountain of synthetic data for training the next generation of models. Later, we'll take a look at Orca Math, which was trained with synthetic data. So as we're going over that paper, notice how they did it, how they used GPT-4 to produce massive amounts of data. This thing sure seems like a standalone product that's going to be doing that. Here's a quick clip from a podcast called Lenny's Podcast. They're talking with Logan Kilpatrick, who's the head of developer relations for OpenAI. Take a listen what he's saying about AI agents, the rollout of GPT-5, and how OpenAI is thinking about approaching AGI.
GPT-5, we touched on this a bit. There's a lot of speculation about the much better version. People just have these wild expectations, I think, for where GPT is going. GPT-5 is going to solve all the world's problems. But I heard from a friend that there's kind of this tip that when you're building products today, you should build towards a GPT-5 future, not based on the limitations of GPT-4 today. So to help people do that, what should people think about that might be better in a world of GPT-5? Is it just like it's faster, it's just smarter? Is there anything else that might be like, oh, wow, I should really rethink how I'm approaching my product?
If folks have looked through the GPT-4 technical report that we released back in March when GPT-4 came out, GPT-4 was the first model that we trained where we could reliably predict the capabilities of that model beforehand based on the amount of compute that we were going to put into it. It's interesting to see, like, does that continue to hold for GPT-5? And hopefully we'll share some of that information whenever that model comes out. I also think you can probably draw a few observations. One of them, which is GPT-4 came out, the consensus from the world is everything is different. Like all of a sudden, everything is different. This changes the world. This changes everything. And then slowly but surely, we come back to reality of like, this is a really effective tool and it's going to help solve my problems more effectively. And I think that is like undoubtedly the lens in which people should look at all of these model advancements. Like GPT-5 is like surely going to be extremely useful and like solve some whole new echelon of problems, but like fundamentally, the same problems that exist in the world are still going to be the same problems. You now just have a better tool to solve those problems. And I think like going back to like vertical use cases, like I think people who are solving very specific use cases are just now going to be able to do that much more effectively. And I think like that is actually a really interesting piece. If you can plan for the world where people become very, very used to these tools very quickly, I actually think that's like an edge. And like assuming that this thing is going to like absolutely change everything. And in many ways, I think is actually like a downside. It's like the wrong mental framing to have of these tools as they come out.
How do you measure success for things that you launch? I know there's this ultimate goal, AGI. Is there some way to track we're getting closer?
Adoption is a great one. I think there's like a bunch of metrics around like, revenue, number of developers that are building on our platform, all those things. And a lot of these, and I don't want to dive, I'll let Sam or someone else on our leadership team like go more into the details. But I think like a lot of these are like actual abstractions towards something else. Like even if revenue is a goal, it's like revenue is not actually the goal. Revenue is a proxy for getting more compute, which is then like actually what helps us get towards getting more GPUs so that we can, train better models and like actually get to the goal. So there's all these like intermediate layers where like, even if we say something is the goal and like you hear that in a vacuum and you're like, oh, well, OpenAI just wants to make money. And it's like, well, really money is the mechanism to get better models so that we can achieve our mission. I think GPTs is our first step towards the agent future. Like again, today when you use a GPT, it's really, you send a message, you get an answer back almost right away. And that's kind of the end of your interaction. I think as GPTs continue to get more robust, like you'll actually be able to say, hey, go and do this thing. And like, I don't need the answer right now. I want you to like really spend time and be thoughtful about this. And like, if you think back to all these human analogies, like that's what we do with humans. Like I don't expect somebody when I ask them to do something meaningful for me to like do it right away and like give me the answer back right away. So I think pushing more towards those experiences is what is going to unlock like so much more value for people.
So Microsoft is making some big moves. Now, while Bill Gates probably doesn't take part in running any of the day-to-day stuff of Microsoft anymore, he does have a keen interest in AI. He's still currently giving speeches about AI and its effects on the world, very positive ones, in fact. It does seem like he's being a champion for some of the potential AI applications, and it looks like he was at OpenAI's offices very early on in that development process, like GPT-1 or GPT-2, kind of having a front row seat into the development of that technology. My take is that Microsoft will be a big winner as this whole AI wave keeps rolling on. And a lot of the various companies and divisions that they've acquired over the years, I think really will benefit their AI research division. I'm talking about things like Minecraft. I think their acquisition of Blizzard will play into it, and many, many other things. But let's dive into this announcement. So Satya Nadella is saying we're announcing a multi-year partnership with Mistral AI as we build our commitments to offer customers the best choice of open and foundation models on Azure. So Mistral AI, for those who are unfamiliar, so they're out of France, out of Paris, France, and they've been developing some pretty incredible technology. So their first Mistral model was very good. It definitely turned some heads, people were noticing, but then they dropped Mistral, which is a mix of experts model, where basically the idea is instead of having sort of one large model doing everything, it's a combination of models, of smaller models that each kind of do their own thing. And this is one of the reasons we think GPT-4 was so effective and so ahead of its time. But now Mistral showed incredible performance for an open source model. Gemini recently dropped their 1.5 model, which they said was a mixture of experts, and that drastically improved their performance. The 1.5 medium, their mid-tier model, is comparable to their large model of the previous sort of generation. So this idea of using mixture of experts does seem to really improve the abilities of these models while also making them faster, more efficient, since you're not using one big model, but a clustering of smaller ones. There does seem to be, as they put it here, performance cost efficiency. And just recently, they dropped Mistral Large. And Mistral Large, as you can see here, is getting very, very close to GPT-4. This is obviously incredible news for the open source community. The fact that we have something as strong or close to GPT-4 that's available open source is obviously a good sign for the future. But not only that, Grok with a Q, the LPU, the language processing unit, they are using the Mistral as well. So you can choose from Llama 2 or Mistral, the 8 by 7 billion parameter model. So it's a mixture of experts, 8 experts each, I think around 7 billion parameters. So let's say we say, explain latent action and machine learning, do not use jargon. So that took, that was fast. Let's see if they have, I would say it's like a 1/10 of a second maybe. So they're saying it took less than half a second to produce that result. It was near instant. So the point here is that what's happening is we have something that is near instant, that is open source, that is now approaching the capabilities of GPT-4. Now it's important to know. So this is Mistral Large. Here we're using Mistral. So once they roll out Mistral Large on Grok, it might be a little bit slower. There might be some differences. Who knows? But I think we can safely say that open source GPT-4, that's lightning fast, it's big. This is kind of where we can have a lot of business uses. This is where we can start hooking into various autonomous agents to do stuff. And once we have a better look into like the pricing for running Grok or something similar, it might be that all the stuff that we wanted to do with this technology is going to be so much cheaper than we realized, than we expected. So it looks like here that it's 27 cents per 1 million tokens at an extremely fast speed. So as you can see here, if you put latency time and throughput, like Grok is, in a league of its own, I think it's fair to say. So I think we are entering kind of like this era of open source AI. And we're going to see some pretty crazy applications of this. I'll show you some specific examples in just a second, but it's important to understand that once again, Microsoft is kind of ahead of everybody here. The speed at which they move in the direction where the puck is heading ahead of everybody else is quite startling. But unfortunately, there's one other organization that moves nearly as fast. And that's the EU. This person, Nathan Benach, I believe he is the person behind the AI State of AI report that he publishes, I think once every year. And so he's saying this is so beyond bananas. EU policy wonks losing their marbles. So yeah, it looks like, less than a day after the announcement, or maybe Microsoft had to warn them ahead of time. But the point is, immediately they're on the case looking at Microsoft and Mistral AIs working together, which was strange because it's a $15 million investment from Microsoft. Microsoft is, of course, a US company. Mistral is in France. By having Mistral have access to Azure, Microsoft Cloud Services. They're going to have all the availability of all the GPUs and whatnot to train their models, to run their models. It seemed like such a win for everybody, for consumers, for Mistral, for this startup that's so rare to have startups that aren't, in the AI tech space, that aren't in the Bay Area, and it's just might be crippled by regulation. So it's bizarre that this is happening. A lot of people in the comments are kind of saying the same thing. It's a major red flag for EU startups. If you can't make minor distribution partnerships with cloud companies, they're at a huge disadvantage. If I have a competing startup and I try to make a deal with Microsoft, I would be at a massive advantage to this French startup through no fault of their own. The only thing they did wrong is they were in the EU. And I know some of you have different thoughts about it. The UK has a number of AI startups, AI companies that are doing great work, making great progress. But this seems like it could be a problem. In other news, the New York Times versus, Microsoft and OpenAI, that whole saga is continuing. We've covered some of the details here on this channel before. So I looked at the New York Times, the claims they were making. I was trying to kind of replicate what they were doing with ChatGPT in their lawsuit. And it seemed strange to me. It didn't seem like it lined up with reality. All of their evidence that they presented, it seemed like I didn't know what they did to get it. They must have done something weird to be able to do that. Whether I thought, could it be Photoshop? Could it be this? Could it be that? Who knows? But after I posted that video, OpenAI comes out and pretty much says, the New York Times isn't telling the whole story. So they're kind of like, they didn't say they were lying, but they said, well, they're kind of just showing what they think will help them win the lawsuit, but it's not like really the truth. And so here is the continuation of that. So this is OpenAI responding to the Times. It's saying that the New York Times said that ChatGPT imperiled the very enterprise of journalism. And they have 100 examples in which GPT-4 supposedly generates several paragraphs of the Times content. The allegations in the Times complaint do not meet its famously rigorous journalistic standards. And they source number 7 here, which is the New York Times Ethical Journalism, a Handbook. They say, we tell our readers the complete, unvarnished truth as best as we learn it. And staff members may not commit illegal acts of any sort. So don't lie and don't commit crimes. So that's good. And then they're saying the truth, which will come out in the course of this case, is that the Times paid someone to hack OpenAI's products. Can I just pat myself on the back just a little bit here? Because this is so I published this video on December 30th, 2023. I went through the New York Times, their complaint, what they submitted to the courts. And we went line by line through kind of like their evidence they presented. And I pointed out why, it just didn't make sense. It wasn't how ChatGPT puts out information, not even just what it says. It's how it organizes stuff, because it has certain sort of formats for answering certain questions. Nothing in their complaint made any sense. And then almost a week later, January 8th, this is where Sam Altman and OpenAI come out and they say the New York Times is not telling the full story. So just, you're getting some cutting edge journalism here from this channel, just FYI. And now I think this was 2/26, right? 2024, right? They're saying, it looks like Times paid someone to hack OpenAI's product, to hack ChatGPT. It took them tens of thousands of attempts to generate the highly anomalous results that make up, they exhibit the sort of proof that they provide. They were only able to do so by targeting and exploiting a bug, by using deceptive prompts that blatantly violate OpenAI's terms of use. And even then, they had to feed the tool portions of the very articles they sought to elicit verbatim passages of, virtually all of which already appear on multiple public websites. The Times' suggestion that the contrived attacks of its hired guns to show that the Fourth Estate is somehow imperiled by this technology is pure fiction. So the New York Times complaint features a number of examples that were generated by the Times after what appears to have been prolonged and extensive efforts to hack OpenAI's models. Notably, the Times does not allege in the complaint that it made any attempt to share these results with OpenAI. The Times kept these results to itself, apparently to set up this lawsuit. So it looks like the Times used a system prompt and told the model to act like a New York Times reporter and reproduce verbatim text from news articles. But they weren't able to do this with any recent news articles. They had to use older articles that were between 2.5 and 12 years before the filing of this lawsuit. Reading the rest of this, it sounds like a lot of this is about the Wirecutter. And the Wirecutter, so it was like a blog by Brian Lamb, and it was purchased by New York Times Company in 2016 for $30 million. And it does product reviews and has links to like Amazon, the affiliate links. So they get paid when you click on those links. And so it looks like the Wirecutter generated $150 million in revenue between 2011 and 2016. So like within the 5 years after they bought it for $30 million, they made $150 million. So it sounds like they don't want to lose the revenue of the Wirecutter. So this is like Bing with Copilot. So if I search like best car seats for toddlers, so it lists some of the best car seats for toddlers here. And so as you can see here, it lists where it's getting that information, The Bump and bestproducts.com, right? And all these sites generate money. So when you go to that site, right, you get hit with this. So you have to, whatever, give them all your information, right? And then all the advertisers, all the cookies. I'm sure there's like a million things tracking right now. And then if I buy this at the bottom left, if I click on this, then they set a cookie that when I go to Amazon, anything I buy from Amazon, they get a commission on it, right? But if I just go to Amazon and I type this in and I buy it there, then they don't get a commission on it. So this is what the other part of the lawsuit is about, I think. So Wirecutter, I think, is like $30 million a year that it's making. And those models rely on the search traffic from Google and Bing to get people to their site, right? Because when they type in a keyword, then they have to select a site. They have to go to that site. That's how they make money. And now that, AI can summarize the stuff for us, we no longer have to click through to the site and click on the cookie notices and the email pop-ups, the opt-ins. We can just get the answers that we want right here. And that's threatening a lot of people's business models. But at the end of the day, this is Bing and the New York Times. Right? This is how Bing chooses to display that information. And, they can do that because they give everybody a chance to opt out of being listed on Google and on Bing, etc. Most websites have this, but you can add one. So it's just a simple TXT file that you add called robots.txt. You just put on the site. And then when the Bing and Google search engines, they have these like crawlers that go about the web finding stuff. And they check this thing because if you tell it in there, like, don't read my site, they're not going to read your site. If you just add this like no index little line to that text file, then you won't get indexed, you won't get crawled, like they'll just leave you alone. But obviously all these sites rely on search traffic. They rely on Bing, on Google for probably 99% of all their traffic. So they're not going to put this in there, right? Because they don't want to opt out of that ecosystem. It's very, very beneficial to them. And if you think about this, if all I want is just a recommendation and a price, then this is all that I need, really. Now, if I want a more in-depth kind of deep dive into why some of these make sense, well, then I would go to, let's say, The Bump, right? And I can read all this information and learn more about it. And then if I click on this button, then it would get paid a commission if I choose to buy this. So if I visit the website and I use the information, then they get paid for it. So that hasn't changed. But if I just want this thing and go to Amazon and buy it, then they're not really providing a service necessarily. They're used to getting paid for this as well. But if I wanted to go to a site, I still can, right? And engage with their pop-ups and all that stuff. So that's kind of interesting to see that more and more of these AI lawsuits are being dismissed with this OpenAI, Microsoft versus New York Times. So that hasn't been decided yet. So it's still ongoing, but it sounds like OpenAI is trying to get some of these dismissed or all of it dismissed. I'm not up on my legal lingo, but I mean, they're saying pretty straightforwardly, hey, the New York Times, they use the term hacked. They hacked ChatGPT to produce those results. And in terms of the, Bing search recommendations that are summarized, all these sites have full control over whether or not they appear in those results, so they can opt out. But, of course they don't because they're making tons of money from it. So we'll see what happens. But the other big thing out of Microsoft is this. Orca Math, unlocking the potential of SLMs in grade school math. So SLMs here is small language models. And a lot of these like Orca stuff that comes out, sometimes it's easy to dismiss it at first, but more and more, I find that these papers tend to be much bigger than we realize at first. Like with Orca 2, only later did it become apparent how important that was going to be. So that sort of using synthetic data to train other models. So oftentimes you'll see why these papers are more important down the road. So these small language models can do very well on, various grade school math, various math problems, while trained on only 200,000 synthetic math problems. So synthetic meaning that it was generated by AI as opposed to humans. And mathematical word problem solving has been long recognized as a complex task for these small language models. And so it's thought we would need at least 34 billion parameters to achieve, this type of accuracy on these math problems. And to reach this level of performance with smaller models, so researchers, what they do is they get these models to generate Python codes. And you see this with GPT-4. Oftentimes you ask it to solve a math problem. And, since it had the advanced data analytics, since those days, it would just write Python code and be like, sure, here's how we would do that. So it writes out Python code, it runs that code, and that code solves that math problem. And so that would, avoid the calculation errors, because if you just ask it to do it, I guess in its head, if that's the right expression, then oftentimes it would fail, it would produce wrong results, and it wouldn't realize it was wrong. It'd be like, nope, it would be wrong and strong. Let's say that. It would be very confident in its wrong answer. Or they would put up a bunch of these models, like 100 of them together, each have generated a result, and then, it would be done using consensus, right? So if 99 of them said one thing and one of them said something different, then it's most likely that the 99 are right. And that 1 out of 100 got it wrong. So it's kind of like mob mentality, I guess. And certainly that worked. That was more accurate in generating answers than just asking one model. But in this work, they're presenting Orca Math, a 7 billion parameter model. So we thought we needed 34 billion to have these kind of results, to have 80% accuracy. But here with a 7 billion parameter, they have 87% accuracy. And this is interesting. So they're saying they used the Mistral 7B. So they're using that open source, the French company that they just announced their partnership with. So, and this paper was from February 16, 2024. So it's recent, but it was done before the announcement was made. So their approach had the following key sort of elements. So they had a high quality synthetic data set of 200,000 math problems. And how it was generated is they would use a multi-agent setup where these agents would kind of work together to create that data. So hopefully they'll go deeper into that. And then they had an iterative learning technique that enabled this small language model, the Orca Math, to practice solving problems, then get feedback on its solutions, on its answers. You would learn from those answers, the solutions and the feedback. And so when they used this iterative preference learning, it looks like it went from, let's say 89.5% to 86.81%. So it improved it, it bumped it up even more. And Orca Math surpasses the performance of significantly larger models, such as Llama 2, 7 billion parameter, Wizard Math, 7 billion parameter, Gemini Pro, and ChatGPT 3.5, this is similar to what we saw with Orca 2. These smaller models, much smaller models, that are trained on a high-quality synthetic data set. So in Orca 2, ChatGPT or GPT-4 would generate a bunch of examples. That's the high-quality synthetic data set. Then Orca 2 is trained on that. And they saw the same thing. These small models would beat out. They would be better than models that are 5 to 10 times bigger. And so here they have the results on the GSM 8K, so Orca Math, so 86. So let's call it 87%, right? So what comes close? Llama 2, nothing. The highest is 56. MetaMath, so it's fine-tuned on the Llama 2, right? The 70 billion parameter model gets 82.3. Wizard Math, so again, fine-tuned on Llama 2, that gets 81.6. This one, OVM, gets 84.7, but they're using that majority rule thing where, you have 100 different answers that it gives and then it votes. So we're not quite comparing, apples to apples there. So Gemini Pro, Gemini Ultra, they have, good scores, but the evaluation method is different. GPT-4, of course, does 97, so it does phenomenal well with the same evaluation method. But I think the point is nothing comes close to this accuracy that's not either much, much bigger or uses a completely different way to kind of generate those answers. And so here's the dataset construction. So that multiple agents constructing synthetic data for this thing, they call that the agent instruct. So they create the variety of agents. So they have a sample math word problems that they use. So a bunch of data sets that they have access to. So they have 36,000 problems available to them. And then they expand how much of those problems they have by creating multiple word problems from each problem in the seed set. And so basically what that does is that creates a total of 120,000 new problems. So they took that 36,000 or whatever, turned it into 120,000. And that uses GPT-4 Turbo or Trubo. They have access to some never before seen OpenAI model, GPT-4 Trubo. Either that or it's a typo. And then they introduced two new agents, namely Suggester and Editor. So the Suggester tries to propose several methods for enhancing the complexity of the problem. And then the editor takes those suggestions and generates an updated, more challenging problem. So you have the seed problem, whatever that is about Joan and her collecting coins. And so the suggester goes, increase the number of hours, more variables for each hour, and more transactions. Then the editor goes, all right. And that agent executes kind of like that, making it more complex. And it looks like that gets them 37,000 problems. And then they train the model. So they're using here Mistral 7 billion on this Orca Math 200K data set. So they use this existing model, right? The open source model for Mistral, the 7 billion one. So it's, I think their smallest one of the smaller ones. And this 200,000 data set that they've created with GPT-4 Turbo, I guess. And that's their synthetic data set. And then they evaluate the results using, by the way, GPT-4. So it looks at the answer that the Mistral model gives it, and then it compares it to the gold short answer, the one that we know to be correct. And so we're telling GPT-4, compare the two, do they match, and final verdict correct or incorrect? So we're just giving it those two options. By the way, so a lot of this stuff, when we read through stuff like this, I think in the past, a lot of people maybe just thought it was curious or interesting, but more and more, for more people, this will become much more actionable. Because as this Mistral model comes to Azure, as chips like Grok are more available, as we're able to create stuff like this for ourselves, looking at how these researchers who basically spend a lot of time doing stuff like this, how do they set up these models to do what they want? Because sometimes the things they ask it, how they prompt engineer what they're asking, sometimes it's obvious, sometimes not so much. And we see this as they test different approaches, they can have very different results. So, I mean, in this example, they're showing you how to have GPT-4, kind of this bigger, smarter model, have it grade the outputs of the smaller model. Now, if you're running a business, in the future, you might have these open source models doing a lot of the work for you, generating various data or poring over the results of the business or doing some research online. And you might have GPT-4, this more expensive model, but that tends to be a little bit more accurate. Have that be the auditor, kind of looking over its answers. And a lot of these documents, a lot of these papers that these big corporations publish, they publish their prompts right there in the paper. And sometimes they even explain why certain prompts work better than others. So the point here being is I think more and more of us will have access to really inexpensive, large scale, these like multiple agents working together to kind of do whatever tasks we give it. And the way we're going to program them won't be in code. It will be in the English language, this sort of prompt engineering thing, and certain ways of asking for what you want them to do will produce better results. So I guess my point is kind of pay attention to the format that they're using to instruct these models to tell them what to do. And specifically something like this, I find quite a bit. This sort of approach, this format is commonly used. So you start with as an expert, or you are a blah, blah, blah. Your role is da, da, da. It's important, right? So you kind of like write out its whole life story, kind of outlining broadly the things that it's going to be doing. But then often the output has to be very specific in order, so you can pull that out and use it somewhere else, for example. So you're literally spelling it out. So use the following format. Do this, output it like this. And I just point that out because, again, Microsoft and NVIDIA, I'm noticing a lot of similarities about how they're prompting stuff. So it's definitely, they're all kind of learning their best practice of how to do this stuff. And you're seeing it here. You're seeing kind of like the master class on how they do it. Even though they're not telling you how they do it, you're seeing their prompts. So I apologize if that was a random tangent. Okay, so the user, here's the question. And then this is like the golden answer. That's kind of like this is the true answer. The Orca Math model, that's the student. That's this one right here. So it answers here. And so the evaluation, the GPT-4, right, given this system prompt, this is the question it's asking. This is the correct answer. This is the student's answer. And so then GPT-4 goes, The student's answer matches the correct answer, final verdict, correct. So we told it here to spell it out, correct or incorrect. So it says error analysis, blah, 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 final verdict, this or that. And that's exactly what it did here. Error analysis, blah, 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 final verdict, this or that. So reasoning goes here, and here you put either A or B. Don't give a long-winded answer here, just the answer. And here are the results. As they keep training it and refining it, the answers keep getting better until it hits its 86.87 accuracy on the test. And the conclusion is that our study provides compelling evidence that the mathematical reasoning capabilities of these smaller language models can be substantially enhanced. And they highlight the importance of innovative learning strategies. So how do we teach these AIs to do stuff? And data set generation methods. So how do we create these synthetic data sets for these models? But the point here is this. So we taught this small model, open source model, to solve math problems by reasoning through them. So it says, first, I got to find the number of days. And then I got to do this, then this, then this. Then I got to do this, and this is the answer. Now, you can probably create something like this at home. You can probably train a model like this on, consumer grade hardware. Or even if it's too difficult right now, probably in the near future, it won't be. It's not going to be too expensive, but you can kind of fine tune it for your own use case. Where could this be, useful? Where could this be effective? Well, let's say you buy things online and you have an extensive process for how to evaluate them. So think things like, real estate would be it. If you have any collector's items, Pokemon cards or whatnot, you can have a model like this analyze a lot of houses very quickly by going through whatever sort of criteria used to analyze it. It checks what zip code it's in. It looks at the images to kind of determine what shape it's in, maybe does some looking online for school districts, accessibility, etc., and organizes all that information into one sort of final score. Let's say out of 100 about how attractive that property is, and then looks at the price and sees, how good of a deal that is. Same thing can be done for stocks, for example. Something like this can be done to go through 10Ks, for example. When these companies publish their reports, it can rapidly go through, kind of highlight the data that it needs, and then output the observations that you need. This can be taught to reply to emails or organize emails in some ways that you trained it to do, maybe forwarding the most urgent of emails to you directly. Content generation could work very well. Let's say you have a list of tweets that are very effective. You can train it to output tweets, maybe have a second sort of agent look over those and try to improve them and create that kind of iterative learning cycle where over time you feed back the information on how well those tweets are doing back into it to kind of refine its outputs. You can use it for HR and recruitment to go through candidates, inventory management if you have like an e-commerce business. If something like Mistral Large, the open source model, if it's fast, it's nearly as good as GPT-4. And if it's very inexpensive, if I recall correctly, they said 27 cents per million tokens of output, then all of a sudden building things like this for your own specific use cases becomes fairly attainable, becomes fairly inexpensive. And each model can do a very small fraction of the whole thing that you're trying to achieve. So for example, if you're trying to set up customer service emails, all the customer service emails comes in, the first agent all it does is sort. So its whole mission in life is to figure out which bucket the email goes into. Is this an email about tracking their order? Is it an email about refunding their purchase? Is it an email about a product specific question? So it puts the product questions in this folder, and then the refunds in this folder, and then tracking in this folder. And that's all it does with every single email. And you keep training and improving it. So it gets closer and closer to 100% accuracy. Let's say you have a product question that they're asking, right? You train the model on all the possible questions that your customers have about it. And all it does is it answers those. And you keep training it, keep improving it until it's able to answer those questions better than you could, than your employees could, etc. So how much will that cost us? So for example, to run something like this, right? You need a system message that tells the model what to do. The customer email has to be read. So that's those words, those tokens have to be considered. And then the response, the output, those are also will have a cost in tokens. So let's say you have a 200 token system message, 300 token customer email, a 500 token response. That's 1,000 tokens. So if I'm doing my math right, it'll cost you in dollars 0.00027 to answer one email or 27 cents to answer 1,000 emails, meaning that a lot of these things will, basically run for free, or it's going to be, a few dollars here and there, right? Maybe the weekly cost for operating a customer service department for a large e-commerce store could be measured in a cup of coffee, right? You skipped going to Starbucks that day and you've just paid for your customer service department for that week or that month or whatever. So an open source models like Mistral, the large one, so something that's equivalent to GPT-4 plus Grok, right? That super fast chip that makes it very cheap, very easy, very fast to run a lot of the stuff. Plus, that it's open source. So basically you own it. Nobody can increase the price on you. Nobody can prevent you from doing whatever you want with it. A combination like this is kind of a game changer. And it's going to be here very soon. I can't wait. I hope you enjoyed that. My name is Wes Roth, and thank you for watching.